Hello. Here's another video. This is part of the calculus series. We're going to be starting talking about limits, and limits are a really super important part of calculus overall. Like we're going to keep coming back to it over and over and over again over the course of the years. So it's important to get a good handle on it. There's going to be more videos coming up this week, or if you're seeing this later on, there are more videos here. Either way, if you have questions, comments, concerns that my videos aren't specifically addressing, or you need help somehow, please feel free to email me. My email is right here. I will be happy to get back to you. Um, so let's talk about this. So we're going to start off with really easy limits. And these limits are easy to the point of you're going to say to me, why are we doing it this way? What's the point of doing what we're about to do? And really, when it comes down to it, 99 times out of 100, these aren't the limits that you're going to be worried about. These are designed for practice so you can get used to the idea of what we're about to do. In the more complicated videos, this is sort of a sort of like a proof of concept. Here we're going to get this new toy to work with. How does it work? You never start out doing the difficult things with your new toy. You always learn first how the pieces move and so you don't break it, right? So that's what we're going to be doing today. And so when I say we're going to evaluate a limit by plugging in the limiting value for x, what that means, we're literally going to just sort of kind of be plugging in for our x value, and we'll talk about what that means and how that gets more complicated later on, but for now we're going to start easy. And so to begin with, I really want to motivate the idea of what a limit is. And, as we go further into this topic, we're going to talk more deeply about it. But for now, imagine you have a function, and I'm just going to draw a squiggle here on the screen. It's going to have to keep going like this. It can't pass back over itself, right? Then it's not a function. But the idea behind working with a limit is, let's say I want to find out what's going on right here on that function. Well, maybe something weird's going on, and I don't want to touch it. I don't want to cause a problem. Maybe you put that right in your calculator, and your calculator blows up because your calculator can't handle it at that point. So what we do is we're going to imagine like a sort of a safe zone around that limit, around that point. And this is what a limit is. We're saying, all right, so here's my safe zone. I can look at that point from over here behind the fence. This is 2020, so this may still be slightly relevant. You want to keep your kid away from Harambe, right? He's out here. We want to stay behind the fence, right? But the thing is, from out here, it's kind of hard to see. So we want to get closer. And so the idea of a limit is that we sort of close the enclosure. We get closer and closer and closer to this point. And in fact, so close that it's almost like we're basically right on top of it. But we always have that fence around the point to keep us safe. So we sort of can look at it from afar almost. So we're going to look at it, and we're basically going to sneak our way in towards this point. Sometimes when there's no danger, we can just jump right to it. Other times, we're going to see there's problems where we don't have a good answer right here for one reason or another. All right? So we're going to look at, these are going to be things that you've seen in previous classes. Like here, look at these four things. You've got, it's just an algebraic expression for all of these, and we're just going to plug it in. So the first thing we want to do is make sure that if we were to plug it in, that it doesn't come out to be something scary. Like, no, dividing by zero is scary. no taking situations that could cause problems, right? That's what we're worried about. So if we plug in 1 here, well, look, we got 1 squared plus 1 minus 2. That's okay. We can get a negative number, right? This is 1 squared, which is 1, plus 1 minus 12 over 1 minus 3. Well, what's 1 minus 3? That's negative 2. So here, what do we've got? We've got negative 10 over negative 2. Hey, this limit approaches 5. So as basically the limit as w approaches 1. So basically as we creep here towards 1, what's the y value creep towards? Right? The x value is creeping towards 1. What's the y value getting close to? So we creep closer and closer. And as we approach w being 1, the y value, the value of the whole expression, of the whole fraction, approaches 5. All right? So all of these are like that. So try number 3, try number 2 or number 4 even. They're the same idea. These all come out very nicely, and they were chosen on purpose so that they don't cause any problems. We're just trying to creep safely right now. We'll creep dangerously later. So go ahead, give these a try. Okay, so now that we've done that, let's try the rest of these. We're going to do the same thing. Okay, t is creeping on 3, right? The limit as t approaches 3. Well, what's this whole fraction approach? Well, let's just plug it in to see, because sometimes it's okay. 2 times 3, well, on top, that's 6, right? T is 3, t minus 2, 3 minus 2 is 1. So safely, we found out that as t creeps closer to 3, as the limit of this function, as t approaches 3, the whole function approaches 6. Same thing here. We're going to do the exact same thing. The limit as w approaches negative 1, what does this whole thing approach? Now here, don't overthink this one. We're going to take negative w. Well, negative w. Well, w is negative 1, so it's negative w. It's positive 1, right? So look what this is. This is the cube root of 1 plus 2, which is the cube root of 3. Now, some of you may be saying, well, but what do I do with that? And the answer is nothing, right? 3 is not a perfect cube. 3 does not have any factors that are perfect cubes. So you can just leave that as the cube root of 3. I would prefer this. Don't give me a random decimal answer. All right? If you are not specifically told in the directions to round in a certain way, always presume to just leave it here. There's no reason to do more. We're done. Why take extra steps, right? Ain't no reason to. All right. Negative cosine of 2w. Well, what is the limit approaching as w approaches 5 pi over 6? Well, let's look. If I take 5 pi over 6 and plug it in for w here, well, that's 2w. What's 2 times 5 pi over 6? This is negative cotangent of 5 pi over 3. Now, it's been a while, so let me pull out my good old unit circle. You'll have to pardon. So 5 pi over 3, that's 1 2/3 pi. So 1 pi, 1/3, 2/3. So it's like right over here. The y value is negative radical 3 over 2. The x value is 1/2. And we're doing cotangent That's cosine over sine. That's x over y. So we end up with, if you'll forgive me, negative 1 over radical 3. And we're in calculus now. It's okay if you leave this here. If this makes you uncomfortable because you've spent the past 12 years of your life, or some of you maybe 11 or 10 years of your life, having it drilled into you that you must rationalize the denominator, and it makes you physically uncomfortable not to write this, sure, you go ahead and you rationalize this. In calculus, we're not so much concerned with this anymore. We have graduated from these small childish concerns. So, but basically, when you're working with a limit, if you are working with a limit, you can always just begin by trying to plug stuff in. It's not always going to work. You're sometimes going to get something ugly, and you're going to have to sort of come to terms with that eventually. But if it comes out to just like a thing automatically, you can just plug it in and be good, you know? So if this is, if you plug in 1 and it comes out with 5, especially if we're dealing with these algebraic things, eventually we're going to make things more complicated. I'm going to give you uglier things to work with, and that's okay. We'll get there. But for now, especially when you're given an algebraic expression, much like these, it is perfectly fine for you to just plug it in and see if it works. It may not work, and then we'll have to go through and do more later. But for now, if you plug it in to something like this and it gives you something good, you know you're fine. All right, well, we'll see you next time.